Hello and welcome to the first video in circle geometry. In this video we will look at two theorems about angles and chords in a circle. But first we have to look at some assumptions. Assumptions are things we won't prove, but it's assumed we know them. Don't worry if this is the first time you've come across these, as they'll become familiar with time. The first is that equal arcs will subtend equal angles at the center of a circle. So if we have a circle and we draw two arcs that are equal to each other, AB and CD, and we reduce those arcs to the center, then the angles formed are going to be equal to each other. So equal arcs will mean equal angles at the center. The second assumption is that equal angles will subtend equal arcs. This is the reverse of the first assumption, what we call in mathematics the converse. So if we begin with a circle and draw two equal angles at the center, then the arcs subtended by those angles are going to be equal to each other. So in this case, equal angles will lead to equal arcs. The converse is not always true, but in this case it is. We will now investigate our first circle property. It's similar to our assumption, and that is that equal chords will subtend equal angles at the center of a circle. Here we are replacing the word arc with chord, but we are going to prove this to be true. In a proof, there are certain steps that need to be followed. The first is declaring the aim of your proof. This can come directly from the question, but is a short intro into what you're trying to do. Because we want to show that if we have equal chords, then the angles at the center are equal, we are trying to prove that angle AOB is equal to angle COD. Next is our data, or what we already know. We will use this information as part of our proof. In this example, we know that the chords are equal, so AB is equal to CD. Next is our proof. We're going to use congruence to prove that the angles at the center are equal to each other. So we begin by naming the two triangles, in triangle AOB and triangle COD. Then we're going to write what sides or angles we know are equal to each other and the reason why we know them. We know that AB is equal to CD, and this is given in our data. We also know that AO and DO are equal to each other because they are radii in a circle. Similarly, we can say that BO and CO are equal to each other for the exact same reason. Our conclusion is that the triangle AOB is congruent to triangle COD because of side, side, side. We can now therefore say that angle AOB is equal to angle COD because matching angles of congruent triangles are equal to each other. We will now prove the converse of this statement, and that is that equal angles will subtend equal chords. Our aim here is to prove the chords AB and CD are equal to each other. This time we are starting with the fact that angle AOB is equal to angle COD, and we'll use this in our proof. We start with naming the triangles AOB and COD. And we write AO is equal to BO because of equal radii, and BO is equal to CO for the same reason. This time, however, we are using the data that angle AOB is equal to angle COD. We have again proven congruence, but for a different reason. Side angle side. We can now say that we have proved our aim that AB is equal to CD because matching sides of congruent triangles are equal. We'll end this video by looking at a simple example that will allow us to use what we've just learned. Our example asks us to calculate the value of each pronumeral in the diagram, giving reasons. We notice that we have to find the angle x degrees and the side y centimeters. At this point you should pause the video and try to reason out the values of x and y. We start by noting that AB is equal to BC, so we can say that angle AOB is equal to angle BOC because equal chords will subtend equal angles. Therefore, our x is 70 degrees. Then we note that angle AOB is equal to angle COD. So therefore, AB is equal to CD because equal angles will subtend equal chords. Therefore, y is 3 centimeters. Note that the two reasons given are not identical, but the converse of each other. Be sure to check out the next video in the series Angle Properties 2, where we will investigate the relationship between the angle at the center of a circle and the angle formed at the circumference. Thanks.